some applications that are more specific to construction. And one I want to start out with, I kind of had this on the plate before we did the test. But after looking at the test, I think it's something I want to definitely talk about a little bit more. This example here is a little bit of an estimating example. It's not showing up? Let me try her again. There we go. Hopefully she's coming through. Okay. So looking at this not quite so simple floor plan. This is actually an assignment that we have used. Go ahead. That we have used for the estimating class for the architectural design program. So I want to start off here with find the materials needed for a beam if the beam runs down the center of the house. So we're looking at the beam running right down the center here. It's going to be 36 feet long. It sits on 5 posts, it says. Well, if it sits on 5 posts, that means that we are going to actually have 6 spans. It takes 5 posts to cut that into 6 spans. So 36 feet, cut into 6 spans. How long is each span going to be? So what's the distance between posts going to be? 36 divided by 6 will be 6 feet. Yes. Thank you. So now that we know that we have 6 feet in between each post, to do our beams, what we would normally do for a beam stack up, and this is the part we kind of skipped last time through, to do a beam build up, what we would do is we're doing a 3-ply beam. Here's our wall, here's our first post, our second post, and our third post. So what we would do is the first beam would start at the wall. Either there would be a beam pocket in the foundation itself or some other way of supporting it at the wall. And we would probably go 12 feet with 2x10, 2x8, 2x12, whatever you use for that beam. Then the second ply, we don't want to splice every ply at the same spot. We want to alternate splices. So the second ply would probably come here at 6 feet and be cut there. And then the third ply would probably mirror the first. So we would start out with a 6-footer. Well, actually, the first ply would just be 12, 12, and 12 to get all the way across the house. The third ply would be the same. The second ply would start out with a 6-footer, then do 12 and 12, and finish off with another 6-footer. So looking at this, we have a total of 1, 2, 3, 4, 5, 6 of the 12-footers, 7, 8 12-footers total. So I need 8 12-foot pieces for the beam, and then 2 of the 6-foot pieces. So that would be the beam build-up for down the center of the house to set the floor. So next, actually I should be careful, this is 48 feet long, that's not 36, so that would change it. 48 feet long. Let's go back and redo it for 48 feet. So for 48 feet long, now when we have 5 posts, how long is each span going to be? Well, we take the total length, 48 feet, and we divide by 1 more than our number of posts. We divide it by 6. That means each span is going to be, what's 48 divided by 6? 8 feet. Perfect. So what we had put up here before, we're just going to go from being 12-footers to 16-footers. So we need 8 16-footers and 2 8-footers instead of 6-footers. Okay, so that is our beam. The next thing we need is the linear feet of sill material. Now, if you recall, sills were just what goes around the top of the foundation. So the linear feet of sills was found by finding simply the perimeter. So if this is a 36 by 48 foundation, how do I find its perimeter? Add up the sides, perfect. So 48 plus 36 plus 48 plus 36. So that's what, 168 feet. So we need 168 feet of sills to finish that off. Linear feet of bridging material. So if we have our beam running down the center here, that means all of our joists are going to be how long? Our joists are going to run from the side out to the beam. How long is that going to be? 18, good. 36 divided by 2 is 18 feet. Since those are over 10 feet, we must have bridging. Well, the bridging is going to have to go all the way down here. That's 48 feet. And it's going to have to go all the way down here. That's another 48 feet. So the total run of the bridging is going to be 48 plus 48, which is 96 feet. Now, to find out the total amount of bridging material needed, we take the total run times 3. So we're going to do 96 feet times 3, which is going to come out to be, what, 270, 288 feet of bridging material. Sheets of flooring required. Sheets of flooring. Anybody remember how to do sheets of flooring? We start out by finding the floor area. How would we find the floor area for this? Well, the floor area is just going to be 36 by 48, correct? So 36 by 48 is going to be 1,728 square feet. So once we have the square footage, we divide by one sheet is how many square feet? What's the standard sheet of plywood or sheeting? 4 by 8, which is how much? 4 times 8 is 32. So we got our 1,728 square feet of floor area divided by 32 square feet per sheet is 54 sheets. That was the one question on this test, the sheets for floor area, that I think almost everybody in the class had right. So you guys did really well on that one. And actually the wall studs we did really well on as well. For the wall studs, we take the perimeter, which we already found up here to be 168 feet, times 12 over 16, or 3 over 4 if you want to use that. So 3/4 times 168 is 126 studs, but then we adjust it. We add 1 for the odd length wall. Well, we have 36 and 48. Are either one of those odd length? No, those are both divisible by 4, so we're okay there. So we don't have to add anything there. We also add 1 for each corner and add 2 for each corner and starter. So there's 4 corners here. So 2 times 4 is 8 that we're going to add for the corners and starters. We add 2 for every door and window. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I missed a door somewhere. 12. So doors and windows, we got a total of 12. Is 24. Perfect. And then we add 1 for every interior wall intersection. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 that we're going to add for those. So what's that add up to? $167 studs. Good. Linear feet and shoes and plates for the exterior wall. That's just 3 times the perimeter. So we have the 168 times 3, which is going to be what, 504, I believe. Number of studs for interior wall. This is something we have not done yet. The number of studs for the interior wall is going to require a little bit more guesswork, to be honest. And what we usually do for interior wall is we just figure 1 stud per foot. And the reason we do 1 stud per foot is because it's really hard to get an exact length. So we're really kind of guessing at the lengths. So we're going to come up here and we're going to see what we can figure out for these interior walls. We will not subtract for closet doors. We will consider that as part of the wall. Just because you got a frame around the door, so that's, you know, that extra framing around the door is figured in by just counting that door as part of the wall. So this room here is 16 by 12. So I'm going to do 12 and 16 is going to give me those rooms, those walls. Now it says it's vertical by horizontal, so that means the number that's listed first is the vertical. So that's saying this is the 16 here. So obviously not drawn to scale. This is saying 9 by 5. So the 5 is going this direction. So I've got 5 here and 5 here. This whole thing here has to be 16 again. So I'm going to put that in as 16. This is saying 16 by 16. So 16 and another 16. This little piece across here, well, if this is 16 and that's 16, that adds up to 32. So that has to be 4 feet across there to finish it up. So now let's come over here. This is 18 by 18. We're just going to count it as 18 by 18 instead of trying to figure out that corner. So 18 and 18. 8 by 6. So 8 and 6. And 3 by 6. So we add all of these up here. 12 and 16 is 28. 38. 44, 54. 70. 86, 90, 108, 126, 134, 140, 149 feet of interior wall studs. Okay, so that part isn't so bad. They said the interior wall studs, it just requires you to use the dimensions in here. And I usually do take a highlighter or whatever if I'm looking at a paper floor plan. And I do highlight the walls out like what I did here. As I write down the dimensions, 12 by 16 and just highlight them out. So I don't count them twice. Otherwise you get here, well, this is 9 by 5. Well, I can count those walls again. Make sure you only need to count them from one room side. The bigger skill I want to address, the one that you guys seem to struggle with on the test. There's 2 of them actually. The bridging we talked about, we'll talk about it again. Was the joists. So let's take a look at the joists. So let's say that this is 36 feet across here. This here is going to be 8 feet and 6 feet. We'll call this here, we'll make this simple on a 16 feet, 16 feet, and 16 feet. So this is 48 foot total. First thing I want you guys to do for me, I want you to figure out what the length of that wall is. I'll give you 30 seconds or so. What's that? Okay, it's not 36, I'll tell you that much.
38.
Careful.
Oh, 34.
34, there we go. You went the wrong way. Since this is 8 feet here and this is only 6 feet, there has to be a 2 foot difference. So that wall is 2 feet shorter than the 36 foot over here. So it is 34. Perfect. Good job. So what I'm going to tell you is I'm going to give you this. That the beam down the floor in this basement is at the center of the 36 foot span. So it goes down here like this. So this is 18 feet here and 18 feet here. So for joists, I'm going to need some 18 footers. So let's start out by figuring out how many 18 foot joists we're going to need. So I'm going to make my list over here, my materials list. I have a span, or a run here of 48 feet that I'm going to need my joists on. And if we're thinking of spanning our, oops, is the video still working? You guys look like you froze up on me. Can you still hear me? Okay, so let's find our joists here now. As we said, our beam is going down the center of this 36 foot span. So it's 18 feet away from this edge. So the run down through there is 48 feet. So we've got to cover 48 feet with those 18 foot joists. So let's figure out how many joists it takes for that section. So in that section there, it's going to be 12 over 16, or 3/4, however you want to use it, times the 48. Now we have to decide, is it going to be +1, +0, or -1? So the big question is, do I need a joist at each end here? So, yes or no, guys? Do I need a joist at each end of this one? Yes, we do. So that means we're going to do +1. So 12/16 times 48 is 36. +1 is 37. So that's going to be 37 of the 18 footers. Now that's not going to be all of them, but I'm going to scratch that in there for now. We're going to need more. Because in this section right here, they're also going to be 18 foot joists. But that only has a run of 16 feet here. So that one's going to be 12 over 16 times 48. Oops, not 48. That's going to be times 16 feet. Do we need a joist at each end of that one? We need one here. Do we need one here? Well, we might not if it doesn't work out perfectly, but in this case, since that's divisible by 4, that last joist will work out to be right on the end there. So in this case, we will need one on that end. So that's going to be a +1 as well. So 12/16 times 16 is 12. +1 is 13. So I need 13 joists for that section. So I need 37. Stick with me, guys. I need 37 plus 13 is going to give me a total of 50. So I need 50 of those 18-foot joists. Now the next section here, this section, how long is that span going to be? Across here, how long is that going to be? This was 18 minus 8. This is going to be how big? 10 foot. So those are going to be 10-foot joists. So I need to figure out how many of those 10-foot joists I need. It is a 16-foot run across there. So that's going to be 12/16 times 16. Now here we already put a joist right here. We already have that one right there. The first joist on the longer span, I would probably make this one the longer ones. So for this run, I don't need a joist at either end. So what that means is when I do this calculation, I'm going to actually do a -1 because I do not need a joist at either of the two ends. So 12/16 times 16 is 12, -1 is 11. So I need 11 of the 10-foot joists. I need 11 of those. Then finally, what length are these going to be across here? If this was 10, we add 6, it'll be 16 feet, right? The other way you could look at it is if these were 18 feet here, 34 minus 18 leaves us 16 feet for over here. So now we need to figure out how many. It's a 16-foot run again. So I'm going to do 12/16 times 16. We said we were going to have one on this end, so that one's there. Do we need one on this end? Yes, we do. So we are going to add one because we need one on both ends. So 12/16 times 16 is 12. Plus 1 is 13. So we need 13 of those 16-footers. So this was, I said, this was the part you guys struggled with the most on the test, was these joists. So for this floor system that I have sketched out right here, we would require 50 18-foot joists. We'd require 11 10-foot joists. And we would need 13 of our 16-foot joists. So that's what we need to put the joists across here. Obviously a little closer than that. Now the next thing I want to talk about is bridging. We need bridging anywhere that the joist spans more than 10 feet. So obviously the span here is 18 feet, so we need a row of bridging across here. That's 48 feet worth of bridging. This span is 18 feet, so we need a row of bridging across here. That's 16 feet worth of bridging. This span's only 10 feet. We do not need bridging there. This span is 16 feet, so we need a row of bridging across here. That's another 16 feet worth of bridging. So what we have here, 48 plus 16 plus 16 is the total run of our bridging. If we add that up, that's 80 feet is the run of our bridging. The amount of bridging needed is equal to 3 times the run. So 3 times 80 feet is going to be 240 feet. Any questions? How many of you guys now are confident you could look at a floor plan and figure out what you need for joists? A few of you?
I guarantee it.
You guarantee it? Well then, let's take a look at one and have you guys try it. I'll make this one a little bit simpler than the one on the test. This is 32 feet across here. We'll make this over here 22 feet. 44-foot run here, 20 foot here. So that makes this, of course, 10 foot and 24 foot. And what we're going to do is we're going to run the beam at the center of this 32-foot run. So that means this is 16 feet here and 16 feet here. So I will tell you this much. You're going to need 16-foot joists, and you are going to need 6-foot joists. I want you to figure out how many 16-foot joists we're going to need and how many 6-foot joists we're going to need. So take a second and see what you can come up with there. We'll figure out where you need the 16-footers first. You need 16-footers all the way across here and then right here. And they're going to be every 16 inches. We have to do each section separately. So you're going to have a 44-foot section and a 20-foot section. So you've got the 12 over 16 times 44. Now that one's going to need a joist. It's right on the corner there. That one does need a joist on each end, so that's going to be a +1. So 12/16 times 44 is 33. +1 is 34. So you need 34 of them across here. How many are you going to need for the 20-foot section down here? Well, it's 12/16 again times 20. I need one on this end. Do I need one on this end? Say yes. So that's going to be a +1. So figure out for what is 12/16 times 20 plus 1? 16, good. So I combine those two together. 34 plus 16 is 50. I would need 50 16-footers. What's the run for the 6-footers? That's just going to be here. So that's going to be 24 feet. So 12/16 again is from our spacing times 24. Now there's already a joist on this end, so I only need a joist on one end of that. So that's going to be just +0. So what is 12/16 times 24? 18, and I don't need to add or subtract 1 from that, so it just stays with 18. So we need 18 of our 6-foot joists. Does that make a little more sense now? Okay. Now the next question is, where do we need bridging? How many feet of run and how much bridging would we need? Well, do we need bridging here? Those are only 6 feet long, right? Less than 10 feet, we don't need bridging. But we do need bridging here. That's 44 feet worth. And we do need bridging here. That's another 20 feet worth. So the run of the bridging would be 44 feet plus 20 feet, which would be 64 feet. So then the amount of bridging actually needed is 64 feet times 3, or 192 feet. So we need 192 feet of 1x3s to make our bridging. What do you think? Okay. The next thing I want to talk about today, oops, not there. We want to talk about slope and pitch. There is a difference between slope and pitch when we talk about a roof. A lot of people, and many contractors I know included, use those terms interchangeably. And they're really not quite interchangeable. Slope, which is what most of us are used to using to refer to the steepness of a roof. Slope is a rise over a run, just like in our graphing. So if I have a roof here, a roof truss, let's say this has a 40-foot span, and let's go 10-foot height. The rise is the 10-foot height. The run, however, is not the 40 feet. The run is from one end to the center. It would be half the span, or 20 feet. So 10 over 20 is our slope. Now we could reduce that to a 1/2, but for a roof slope, we almost always express it as out of 12. So we would do 10 times 12 is 120. Divided by 20 is 6. So that roof has what we would refer to as a 612 slope. Pitch is slightly different. Pitch is height over span. So the height of this roof is still the 10 feet, but the whole span here is 40 feet. And pitch is fully reduced. So 10 over 40 reduces to 1/4. So this roof would be referred to as a 1/4 pitch. The reason there's a difference, if you guys were to go on in this program and to continue on into the second semester of math, we'd go into trig, and we'd actually use trig to break down roof trusses. Slope, oops, come here. Slope up here is most commonly used for dealing with roof trusses. And when you're dealing with a roof truss, the angle that you have to cut these boards at the bottom, this angle right here that you have to cut, is calculated off of that slope. It's actually an inverse tangent of that slope. So an inverse tangent of 6 divided by 12 would give you the angle of your cut on the end of that top chord. So that's why slope is used, like I said, primarily for trusses. It's for determining those angles of cut. Pitch is used primarily for the old ridge beam and rafter systems. In a ridge beam and rafter system, you had your walls, and somewhere you're going to set a ridge beam, then your rafters are just going to be put on top of that. Like that. Well, the height of that ridge beam above the top of the walls here, that height tells us how steep the roof's going to be. And what the pitch is doing is determining how high that beam needs to be. So let's say we have a 1/4 pitch here, and our span here across from the outside of one wall to the outside of the other wall is 28 feet. Well, we could use that pitch then to find this height here. We just take the span times the pitch. So for this one, it's that span of 28 feet times the pitch of 1/4, that's 7 feet. So we're going up 7 feet above the top of the walls to where we put the top of that ridge beam. So I'll have you guys try something here. So let's say here's my walls. The outside to outside distance, or the span here, is 32 feet. We have a ridge beam mounted up here at a height of what do I want to put up there? Let's go a height of 4 feet. What is the pitch? Remember, the pitch is the height of that ridge beam, which is 4 feet, over the span of the roof, or the distance from outside of wall to outside wall, which is 32. 4 over 32 reduces to a 1/8 pitch. So what if I have a roof? Oh, let's see. Let's put in a height here of let's put this at 36 feet across here. And let's make this 6 feet high. What is the slope of this roof? Well, the rise is going to be 6 feet, but what's going to go on bottom here? For slope, I don't use the whole 36. What do I use? Half of it. Good, 18 feet. So 18 feet goes there. And then to actually find that slope, I have to use a proportion where I put my slope over 12 here and I cross multiply and divide. 6 times 12 is 72. Divided by 18 is 4. So that's 4 over 12, or a 412 slope. Okay, that takes us up to break time. So let's go ahead and take 3 minutes. Have a short break, and we'll come back at 2:48 and start up again. Go ahead and pick up again. Okay, so now I want to reverse this a little bit. If I tell you that this roof here has a 3/4 pitch, and it has a span of 24 feet, how high above the walls does that ridge beam have to be mounted? Well, to find that height, go ahead and say it. No? Okay. So that height is going to be our span times the pitch. There you go, perfect. 24 times 3/4 does give us 18 feet. So that'd be 18 feet above. So how about if we have a roof that has a span of 48 feet and an 8/12 slope. What's the height of this going to be? Well, the first thing we need to know is our run. What's the run going to be here? Half of the 48 gives us 24 feet. So now we've got our 8/12 slope. What we're looking for here, the height is the rise. So it's going to be the height over the run of 24. You got it. We cross multiply and divide. 8 times 24 divided by 12 is 16. So that height is 16 feet. Okay. So now what I want to look at is then how do we convert if we have something given as a slope? Let's say you're given an 8/12 slope. How can you convert that into an equivalent pitch? And it's actually way simpler than it looks. To convert an 8/12, or to convert any slope into a pitch, what we are going to do is you take the numerator, the 8, and you put it over, instead of 12, you put it over 24. So 8 over 12 becomes 8 over 24, and then we simply reduce that fraction. 8 and 24 can both be divided by what? 4 will work. 8 divided by 4 is 2. 24 divided by 4 is 6. We can still divide both of those by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So an 8/12 slope is a 1/3 pitch. Just drop it on the table there. So what if we have a oops, gotta keep going the right way. Let's say we have a 9/12 slope. And we want to convert it into an equivalent pitch. Well, we're going to take our 9/12, and what are we going to do to it? 9 over 24, good. What can both of those be divided by? 3, right? 9 divided by 3 is 3. 24 divided by 3 is 8. And that's as far as I can reduce that. A 9/12 slope is a 3/8 pitch. So in your notes, tell me what a 10/12 slope is going to be as a pitch. What's the equivalent pitch? So 10 over 12 as the slope becomes 10 over 24. Both of those can be reduced by 2. So that gives us a 5/12 pitch. That's one that gets confusing because 5/12 is also a common way of expressing a slope, but it is a 5/12 pitch. Okay, did Mr. Berghammer give you guys the worksheet with these on them?
Yes, he did.
Okay, so what I want you to do is on that first worksheet where it says convert to a pitch. I want you guys to do those first 3 there quick. So the 4/12 slope, the 6/12 slope, and the 3/12 slope. Convert those to pitches quick, and we'll go over them in just a couple minutes. Let's take a look and see how you're doing on these. So for the 4/12 slope, to turn that into a pitch, what's going to be our first step? 4 over 24, good. And those can both be divided by what? 2 or 4, yep. And if we divide by 4, it reduces to 1/6. So that is a 1/6 pitch. So for the 6/12 slope, what's that going to become? Perfect. 6 over 24. Both of those can be divided by 6, so it reduces to a 1/4 pitch. And finally, the 3/12 slope will become what?
3 over 24, that's going to reduce to 1/8.
Perfect. 3 over 24. And both of those divide by 3, which reduces to a 1/8 pitch. Now, going the other way, if I give you the pitch and I want to know the slope, let's say I have a 1/3 pitch. To do a 1/3 pitch, to turn it into a slope, what we do is we take the top number times 2. So 1 over 3, we're going to take the 1 times 2, which is going to be 2 over 3 now. Then we set that equal to, we're going to do a proportion of blank over 12. So 2 times 12 is 24. Divided by 3 is 8. So that is actually an 8/12 slope. So we might have a 1/2 pitch. Convert that into a slope. I take my 1/2. I am going to double the numerator. So I'm going to multiply that numerator by 2, which is going to give me what? 2 over 2. Very good. Then we figure out what's that have to be over 12? Well, we'll cross multiply and divide. 2 times 12 divided by 2 is 12. So that is a 12/12 slope. Let's say we do a 1/8 pitch. Let's change that to a slope. So what are we going to do to our 1/8? We multiply the numerator times 2. So 1 times 2, and this is going to become 2 over 8. Good. Now we set that equal to 12. And we cross multiply. 2 times 12 is 24. Divided by 8 is 24 divided by 8? 3. So that's a 3/12 slope. Come on. So let's say we have a 3/8 pitch. I want to convert that to a slope. Tell me where to start. So 3 times 2 is 6. I got 6/8. Perfect. 6 times 12 is 72. Divided by 8 is 9. So that is a 9/12 slope. So in that packet, the next section, the next 3 problems were convert to a slope. So I want you to do those in your notes quick. We got a 1/4 slope, or 1/4 pitch, I should say. We have a 2/3 pitch. And we have a 1/6 pitch. Convert those to slopes quick. So for a 1/4 pitch, what do we do? So that becomes 2/4, good. Perfect, so that's a 6/12 slope. 2/3 pitch, what do we do? 2 times 2 is 4/3. Yeah, 4 times 12 is 48, divided by 3 is 16. That is a 16 and 12 slope. And then the 1/6. Times 2 is 2/6, yep. Perfect. We cross multiply 2 times 12 is 24. Divided by 6 is 4. That's a 4/12 slope. Good job. Okay, so then the next thing I want to do is I want to take a look at converting to the nearest fraction of an inch. Where this would come up is, let's say that we have a bookshelf that we're making, and we want to square it up. Let's say this bookshelf is 32 inches by, let's just go 48 inches tall. If I want to know what the measurement should be corner to corner across this, I could go off the fact that I want that to be a right angle. This distance here would be a squared plus b squared equals c squared. Well, I can take a shortcut and I can use the square root of 48 squared plus 32 squared. So square root 48 squared plus 32 squared. I get 57.6888. Well, if we're measuring this with a tape measure, where on earth is 57.6888 on our tape measure? Well, what we need to do is we need to convert that to the nearest unit. We need to decide if we have to be to the nearest 8th, 16th, 32nd, what measurement unit we need to be closest to. So let's say I decide I want this to the nearest 16th of an inch. So what I have to do is I have to take the 57, that's whole inches. We're not going to touch that. So that's 57. We need to figure out what fraction we can get from that decimal of 0.6888. So I'm going to turn that decimal into a fraction in the easiest way I know how. And the easiest way to turn anything into a fraction is to just put it over 1. So that's 0.6888 over 1. Now right now that has a denominator of 1, and I want it to have a denominator of 16. So I'm going to multiply. To turn a 1 into a 16, I multiply it by 16. So 1 times 16 is 16. I take my 0.6888 times 16 as well. And that gives me 11.02. What that is telling me is that this is between 11/16 and 12/16. It's pretty obvious which ones it's closer to. It's closer to which one? The 11/16. So that's going to be 57 and 11/16 of an inch. And this is a skill that actually comes up quite a bit if we get a fraction of an inch and we need to convert it to the nearest 8th or the nearest 16th. Let's say we're given 4.0 .293 inches, and I want it to the nearest 32nd of an inch. To put that to the nearest 32nd of an inch, I take the 4, the whole inches are going to come off. Then I take that decimal, .293, and again, I make it into a fraction the easiest way I know how. I just put it over 1. And right now it has a denominator of 1, and I want it to have a denominator of what? 32. So I take my 1 times 32 to turn it into a 32. But if I multiply the bottom of the fraction by 32, I have to multiply the top of the fraction by 32. So .293 times 32 is 9.376. So that is telling me that this is between 9 30-seconds and 10 30-seconds. Which one is it closer to? 9 for it's 9.3, so yes, it does round down to 9 30-seconds. So that's 4 and 9 30-seconds of an inch. Well, we're going to add another level to this. If I give you 31.717 inches, and I want it to the nearest 1/8 of an inch. But what I'm going to do is I'm going to say I want this expressed as feet, inches, and then eighths. So the first thing I have to do is I'm going to start with this 31 inches here. And that is 31 inches, but how many feet can I get out of that? So I'm going to take my 31 and I'm going to divide by how many inches are in a foot? 12, good. So that 12 is going to go to the 31 twice. 2 times 12 is 24. How much is going to be left over? 7, right? 31 minus 24 is 7. So that's saying I have 2 feet, 7 inches, but I still have to come up with my fraction of inches as well. So now I still have the .717 here that I have to turn into the nearest 1/8 in this problem. So I put it over 1. What am I going to multiply by? 8. Very good. So 1 times 8 is 8. .717 times 8. 5.736. Now this is saying that we're between 5/8 and 6/8. Which one are we closer to? Yeah, because it's 5.7, this time we're closer to the 6/8. That is going to reduce to 3/4. So that is 2 foot, 7 3/4 inches. So if I give you 131.908 inches, and I want it in feet, inches, and eighths again. Yep, just set it on the table there for now. Thanks. So first thing I want to do is I want to start out with that 131 inches, and I want to split it into feet and inches again. So 131 divided by 12. To be honest, most of you aren't going to do this by hand like this, so let's put this on the calculator. So I have 131, and we're going to divide it by 12. 10.916. That means we're going to get 10 feet out of that. So we're going to subtract off that 10 feet, and we're going to convert it back into inches by multiplying by 12. So that's 11 inches. So that's 10 feet and 11 inches. And now we got to figure out what our fraction is. Where do I go to start figuring out my fraction? What do I do? .908, and what do I do to it? Over 1, good. Now what? I'm going to the 8th, so I'm going to multiply by 8 on top and bottom. So 1 times 8 is 8. 0.908 times 8 is 7.264, I believe. So that's between 7/8 and 8/8. Now 8/8 would just mean we add another whole inch, but this one is closer to 7/8 because it's 7.2. If that were 7.5 or above, that would be the 8/8. We would just add another whole inch to this. But since it's not, it's 7/8. That is 10 foot, 11 and 7/8 of an inch. Let's do one more where we start out with inches, and then we're going to switch to starting out with feet. And I'm going to do this whole one, all of this one in the calculator. So I have 88.316 inches. And again, I want to put it in feet, inches, and eighths. So I'm just going to put 88.316 in my calculator. I'm going to do this all within the calculator. So the first thing I'm going to do to that 88.316, that's inches, I need to get my whole feet. So I'm going to divide by 12. That's 7.3596666. That is telling me that I have 7 whole feet here. So now I'm going to take off that 7 feet. I'm going to subtract 7. And I'm going to turn what's left over back into inches by multiplying by 12. So I get 4.316. That means I have 4 whole inches. Now I'm going to take that decimal and turn it into my fraction, into my eighths. So I'm going to subtract off the 4 whole inches. I have 0.316. I want to turn it into eighths, so I'm going to multiply by 8, which is 2.5. 2.5 is between 2 and 3. It rounds to which one? 3. So that is going to be 3/8. So any questions on that? Okay, so next, what if we start with feet? What if I have 6.29 feet? And I want to put it in feet, inches, and eighths of an inch. Well, the first step, I've got 6 whole feet, so I'm just going to take the 6 feet off. Then I have my 0.29 feet here. I'm going to change that into inches by multiplying by 12. 0.29 times 12 is 3.48. So that means I have 3 whole inches. I have to figure out what my fraction of an inch is. So I'm going to take my 0.48, put it over 1, and I'm going to multiply by 8 on top and bottom. 1 times 8 is 8. 0.48 times 8 is what? 3.84, I believe. That's between 3/8 and 4/8. Which one's it closer to? 4/8, which would reduce to 1/2. So that is 6 foot, 3 1/2 inch. Now again, most of you aren't going to do this out by hand. You're going to use a calculator. So let's go through that step, or those steps on the calculator. Let's say we've got 12.561 feet. And again, we're converting it to feet, inches, and eighths. Well, I'm going to start by just taking the 12 feet off of here. So I'm going to punch in the calculator as the 0.561. And I'm going to turn that into inches by doing what? times 12. So 6.7, so that's 6 whole inches. I got to figure out what my fraction is. So now what am I going to do here? Subtract the 6, and then what? Turn it into eighths, multiply by 8. So 5.8, which is going to round to 6/8, which reduces to 3/4. So that's 12 foot 6 3/4 of an inch. Okay, so what I want you guys to do for homework today is on that worksheet that you've been given. On the last page of that, problems 3 through 14 deal with what we just did, converting feet into feet, inches, and sixteenths, or feet, inches, and eighths, I should say, and converting inches into feet, inches, and eighths. So I have you do 3 through 14 on that last page for our next class. I will see you guys again on next week, Wednesday, it looks like.